Hello everyone, welcome to Nrcm and this is Shravani and I'm going to explain about operating system and the unit is 5 and the topic is file allocation methods. So there are different types of file allocation methods. So first we are going to see the contiguous allocation and this belongs to contiguous allocation method. This belongs to contiguous allocation method. And what is the in general what is contiguous allocation method? So contiguous allocation, it is one of the most used methods for allocation, and the contiguous allocation means we allocate the block in such a manner as shown in the diagram. So that in the hard disk all the blocks get the contiguous physical block, so as shown in the diagram. So in the directory, like see here we have three files. Okay, consider here we have the in the file allocation, like there is a file name, start block, and the length. So in the table we have mentioned start block, length, and all the files. So we can see in the table for the each file we allocate the contiguous block. I wanted to represent with this highlighter. So where is file A? Here there is a file A and it is start block is 2. Okay, it is starting from 2. Start block is 2 and the length is 3, means contiguously 3 files have been stored. So this is 1, 2 and 3. So up to 4 this file A is present. 4 blocks or 3 blocks are contiguously allocated to this file A. So next coming on to the file B. So what is the start block? Start block is 9. I hope you can see this color. So where is 9? So 9 is here. So from 9 to how many blocks it has been allocated? The length is 5. So it has allocated like 1, 2, 3, 4, 5. So up to 13. So up to 13. So from 9 to 13. So this belongs to the B. So here the contiguous memory will be allocated. And so on. So coming to the next file C also the same is happening. So like this example of this contiguous allocation as I have shown here, and there might be some advantages, like there are advantages. Now what the advantages are, like the contiguous allocation method gives excellent read performance, and this contiguous allocation it is very easy to implement. And the contiguous allocation method, it supports both types of file access methods, that are sequential and direct access also. And here it is little bit fast because in this method number of seeks is less due to the contiguous allocation of the file block. This you need to remember. And next obviously there will be some disadvantages, and the disadvantages are like sometimes disk can be fragmented. It might be external or internal, so sometimes it can be fragmented, and it is difficult to increase the size of the file due to the availability of the contiguous memory block. So if I want to increase, so if it is, see here, if I this is already 5, if I want to make it 6, so consider, suppose this is also filled, this 14 is also filled by other block, so then there is no space over here and I cannot increase the length of the file. So this becomes a problem in this contiguous like allocation. So next moving on to the like indexed next moving on to the indexed allocation. So I just wanted to see, like as shown in the diagram here, like it is used to save the, based on the index for each file, there some index will be allocated. So if there is a file A, so if there is, like suppose if this is a file and it contains this many blocks, and for each block different index will be allocated, like index or address. So it is in a number format, so it will be allocated, and based on the index, so every, and here you can see like, so only one folder will be containing all these indexes. So first it is like 1, so next is on 8, 3, 14, 28. So it is, so from this from this point, so all the files will be linked. So all, if we want to if we delete any part of the file, So then what happens, the allocation, if we delete anything, like suppose I have deleted this 28, so this 28 will be deleted from this table, index table, okay, from this table, and this 28th file also it will be removed and the link will be removed from here. Okay, so mean this helps, like the advantage is like it will be very fast, obviously, because I mean, and it space and it saves the space also. Like see if these all are full, consider. So I mean, it's these files are, I mean, if the system is full or if the memory is full, wherever the space is there, then the spaces will not be wasted. So that is one advantage here, and the disadvantage is like, so separate memory is required to store this index table as well. So this will be the disadvantage. And next, moving to the file structure or file system structure, like you can see, like file system provides an efficient access to the disk by allowing data to be stored, located and retrieved in the convenient way, as we all know that. And a file system structure, it must be able to store the file, locate the file and retrieve the file. So here most of the operating systems, they use the layering approach. So layering, as it is showing, like one after the another, so they use the layering approach for every task including file systems. So here every layer of the file system is responsible for some activities. So as it shows, like different layers are responsible for different activities. And so first is like application programs. So first layer is of application programs, and second is of like logical file system, and third layer file organization module, fourth is basic file system, input output control and devices. So here what happens, actually hard disks have two important properties that make them suitable for secondary storage of files in file system. So first I mean blocks of data can be written in place, and second means the whatever the blocks are there, so they can be written in this place, and they are direct access and allowing any block of data to be accessed with only minor movements of the disk heads and the rotational latency. So and but this file system, what it will do, like, and here disks are usually accessed in physical blocks, as we all know that, rather than a byte at a time. So it rather than a byte at a time. So your file system, it organizes the storage on disk drives and can be viewed as the layered design. So first, the lowest layer are the physical devices, and they contains the I mean which is and they contains the magnetic media, motors and controls, and the electronic, just a minute. So here modern disk put more and more of the electronic controls directly on the disk drive itself, leaving like relatively little work for the disk controller card to perform. So this is the lowest, lowest layer of the physical devices. Next comes the input output control, IO control. It can consist of the, here it contains the device drivers, like some special software programs, like which are written in the assembly language and which communicate with the devices by reading and writing the special codes directly to and from the memory addresses, which are corresponding to the controller card registers. And each controller card or the device on the system has a different set of addresses that are like registers or ports, so that it listens to, and a unique set of command codes and results codes, I mean, and it generates a unique set of command codes. So next coming is like basic file system. So basic file system level works directly with the device drivers in terms of retrieving and storing the raw blocks of data without any consideration for what is in each block. So depending on the system, like blocks may be referred to with a single block number, like any of the block number can be given. So with head sector cylinder combinations. Next is file organization module. So it knows about the files and their logical blocks and how they map to the physical blocks on the disk. In addition to the translating from logical to physical blocks, the file organization module also maintains the list of free blocks and allocates free blocks to files as needed. So next comes to the like last is like the application programs. So and this logical file system, what it will do, so this lab it manages the directory structure and the mapping of the file names to file control blocks or FCBs, which contain all of the metadata as well as the block number information for finding the data on the disk. So the layered approach of the file system means that much of the code can be used uniformly for a wide variety of different file systems, and only certain layers need to be file system specific. So common file systems in use in like in Unix are like as we all know that FAT, NTFS, like CD-ROM systems. So for Linux, the extended file systems are it is the names are like ext to extended 2 and extended 3, and normal for Unix is like FFS, Windows systems, FAT32, and TFS. These are the different file structures. And next, moving on to the file system implementation. As we all know that like file system implementation. So here the file system stores several important data structures on the disk. So first is like you can say like a boot control block, or you can say like boot block in the Unix, or the partition boot sector. We'll be calling it as partition boot sector in the Windows. It contains the information about how to boot the system of the disk, and this will generally be the first sector of the volume if there is a bootable system loaded on that volume, or the block will be left vacant otherwise. And next you can say that volume control block, like volume control block, it is like also called as a master file table. So in Unix, it is super block, in a master file table in Unix and super block in Windows. So which contains information such as the partition of the table, number of blocks on each file system, and partition and pointers to free blocks and free FCB blocks. And next comes to the directory structure. So as we all know that it contains the file names and pointers to the corresponding FCBs. Normally Unix uses inode numbers and NTFS uses a master file table. Generally coming to the file control block, that is FCB, it contains the details about the like in file control it contains the details about the ownership, like size of the file, permissions, dates, etc. will be stored, and Unix stores this information in inodes and NTFS in the master file table as a relational database structure. So well, this is all about the like a file system implementation. I hope you all understood. And here as it is shown like different, as I discussed, so like different file permissions, create access right, file owner, group ACL, like file size, pointers to the file blocks, everything will be implemented within this file system. And thank you everyone.